I'm Anil Kumar. Welcome to my series on discrete functions. Here is question number 7, which is write the recursive formula for the sequence 1, 11, 1, 1, 1, 1, 1, 1, 1, and so on. You can always pause the video, answer the question, and then look into my suggestions. Now, how do we solve this? Recursive formula means we have to write with reference to the previous term, right? So here we have 1, and then we have 11, and then we have 3 ones. Then we have 4 ones, and so on. Now we need to figure out how from the first term we get the second term. So clearly we can write t1 as equal to 1, and now what is t2? Okay, so how do we get from 1, 11? Well, you could think like this. I have 1, and then 10 times 1, if you add to this, which is 10, right? 1 plus 10, correct? Will give you 11. So the previous term, adding 10 to it, gives us 11. Now how do we get from 11, 1, 1, 1? So from here to here, we do understand that times 10 when you add, it helps. Now if I do times 10 and then add, what do we get? Okay, so if I look at the other way, that is times 10 the previous number and then adding 1, it may make sense, right? So if I look into this going from here to there as 110 plus 1, we do get 1, 1, 1. Do you get the idea, right? So if I think like this, I get my formula, right? So what we are doing here is we are just multiplying the previous term by 10 and then adding 1, right? So if the first term is t1, then tn could be equal to 10 times n minus 1 plus 1. So that is going to give us this particular sequence. Is that clear to you? Right? So that is how we could actually generate a recursive formula for the given sequence. Correct? Now let me add a question here for you, and we'll call this as question 7b. And the question for you is, find the general term for this sequence. Okay, so that becomes a question for you. So challenging question. Let's move on and take the next question now, which is question number 8. Question number 8 here is, does the number 83 belong to the arithmetic sequence 6, 13, 20, 27, and so on? So we are given a sequence where A is 6, D is 13 minus 6, which is 7, right? So the general term Tn will be A plus n minus 1 times D. So in our case, it is going to be 6 plus n minus 1 times 7, or 6 plus 7n minus 7, or we get 7n minus 1, right? 7n minus 1. So from here, we do get a formula, which is, let's rewrite the formula. We get the general term Tn as 7 times n minus 1. So multiple of 7, 1 less than that. That is what we are expecting. So do we get 83? That's the question, correct? Okay. So 7 times, if I divide this by 7, then what do I get? 7 goes 1 times, and then we get 13. 7 times 2 is 84, right? So what is 7 times 12? 7 times 12 is 7 times 2, 14, 4, 1, 84. And when you do minus 1, we do get 83. Do you see that? Therefore, we can say that 83 is 12th term. Right? So does this number belong to the arithmetic sequence? Yes, it does. It belongs to the sequence. And it is 12th term. Is that clear? So that is how you could answer question number 8. And now let's look into the next question, which is question number 9. It says, find the general term for the following geometric sequence. So the sequence is geometric given to us. We have square root of 6, and then we have 2 square root of 3, and then we have 2 square root of 6. Now when you have this kind of a thing, it's a good idea to write all with same likely terms, right? Okay. So square root 6, how do I make this as square root of 6? 6 is 3 times 2, right? 6 is 3 times 2, right? So now, if we have this 2 outside, it basically means that if I take it in, we will write like this. Let's do like this. If I take it in, it will be like 4, right? So we have square root of 4 times 3, 12, right? Now if I take this in, I get square root of 4 times 6 is 24, right? So when you see this sequence, you can clearly see that the value of r is square root of 12 over square root of 6, correct? So that goes, basically it is 12 over 6, or it is square root of 2, right? And the first term a is square root of 6, correct? So we can now write the general term. General term for a geometric sequence is Tn equals to a times r to the power of n minus 1. Now in this case, a is square root of 6, r is square root of 2 to the power of n minus 1. That becomes our general term, right? And for any discrete sequence, we are saying n belongs to set of natural numbers. Perfect. So that is how you'll get your general term, Tn as equals to square root of 6 within bracket square root of 2 to the power of n minus 1. That brings us to the last question of this discussion on discrete functions, sequences, and series. We have basically concentrated on sequences. Question number 10 is, the fifth term of a sequence is 7 and the seventh term is 5. Okay, so we have fifth term, right? Then sixth is missing. Okay, seventh term, right? So it says that the fifth term of a sequence is 7 and the seventh term is 5. Let's see. Each term in the sequence is sum of previous two terms. So each term is sum of previous two terms. What is the ninth term in the sequence? Okay. So we have to find the ninth term. Okay. So we don't know the 8th and we need to figure out what is the ninth term. Now since we are given that each term in the sequence is sum of previous two, that means 5 is 7 plus something is 5. That something could only be minus 2, right? 7 plus minus 2 is 5. Is that clear? So we get this term minus 2. Now, to get the next term, I have to add these two to get the 8th term, right? So 5 minus 2 is basically 3. So we get the 8th term. And to get the 9th term, what should I do? Well, I should add these two. 5 plus 3 is 8. So that is our answer, right? So therefore, ninth term is 8. Is that clear? So by the logic given to us, we could actually figure out how to find the ninth term, right? So I hope that helps you to understand how to solve basic questions based on discrete functions sequences. Let's begin with the very basic concepts first. So when we say discrete functions, what does that mean, right? So let's look into this word, which is discrete function. Let's take a very simple example and let's say function notation f of x. Normally we write y, right? So let's say we have f of x is equal to 2x plus 1. Now this is a function. Now when will it be discrete function? It is going to be discrete function if and only if x belongs to set of natural numbers. Perfect. That is important. That means if I say first 5 terms, in that case you have to use the values of x as 1, 2, 3, 4, 5, right? So when I say x belongs to set of natural numbers, it means x belongs to the set of natural numbers. Now natural numbers do not include 0, right? Which are like 1, 2, 3 and so on. Is that clear to you? Perfect. So that is very important to understand. So discrete functions, if I write a function like this under this heading, and if I tell you to write down the first 5 terms, you have to replace x with 1, 2, 3, 4 and 5. Clear? So this is first part. Second part which you should understand is sequences and series. Now so many times both these terms are used together. Well, what is the difference between these two? That is kind of important to understand. So let's get back to our function. So if a sequence will be, if I put x as 1 in this case, I get 2 plus 1 which is 3. And then if I put 2, I get 5. So every time it is increasing by 2, right? So we could write this. Now if I write like this, that is a sequence. Correct? The same thing if I write like this, 3 plus 5 plus 7 plus 9 plus 11 till, let's say some term, 21. Okay. So that becomes, I should write plus here. So when I use the operation of plus, adding, right? So then it becomes series, correct? So basically the difference is we are only talking about terms in a sequence, right? And in the case of series, we are looking into sum of the terms. Correct? So that is how they are related. So when we say sequences, we have to write with comma. These are separate elements following a pattern. But when we say series, we are looking for their sum, right? So we're talking about adding them, operating on the sequence, right? So sum of the terms in a sequence. Correct? Now, when we talk about sequences and series, there are two common series which we'll always look into. One is arithmetic and one is geometric. Correct. So in general, when we are talking about arithmetic sequence, in that case the first element will be a and the second will be a plus d, then we have a plus 2d, so on. And in geometric series, sequence I should talk about. We'll concentrate more on sequence. We are saying the first term is A, the second is AR, right? The third term will be AR square. So there is a multiple factor R, right? So that is how it is going to progress. Perfect. General term, so these are individually called the terms. General term Tn for arithmetic series will be A plus how many D's differences have been added? N minus 1, right? And in this case, the general term will be A times R to the power of, see, here the power is 1, 2, right? So in the first case, it is 0, R to the power of 0. We cannot use 0, right? So we use N minus 1. Do you see that? Now, if N is 1, so in both the cases, you can see that N belongs to set of natural numbers, correct? So if I put 1 here, we get the first term, correct? So what we have written here is, this is the formula for nth term, correct? So in nth term, this is our first term, that is common difference. Correct? Now here, R basically is a common factor. Is that clear to you? Right, so that is kind of important to understand. Now as we move forward, a bit difficult concept is to understand about arithmetic mean and geometric mean. So I'm putting that in a block. So if I have, let's say, 3 terms, which is A and something in between, and then we have, let's say other term as, okay, let's say C, right? Okay, and in between term is B. In that case, what is B equal to? B is the average value, right? So in this case, B will be equals to A plus C divided by 2. Now this is called arithmetic mean. Is it okay? On the other hand, if I have the terms A, B, C, but they are in geometric sequence. Let me write geometric. This was arithmetic sequence, correct? If they are in geometric sequence, in that case, the ratio of B to A will be equal to C to B, and therefore B will be equal to square root of AC. So this is called geometric mean, correct? So this is kind of important. We have questions related to arithmetic mean and geometric mean also in this particular list. Perfect. So we'll see how we can work with arithmetic and geometric mean when we talk about sequences, right? So these are the center numbers which we may have to figure out, and they may lead to some bonus or challenging questions at times. So I hope the basic concepts are absolutely clear. Now let's begin with the solution of our questions one by one. So if we have 3 numbers in arithmetic sequence, in that case B, the center number, is the average of 2, and it is called arithmetic mean. But if we have 3 numbers following geometric sequence, in that case the center number is equal to square root of AC, that's side numbers, and it's called geometric mean. Now in this particular video, we'll have few examples where we are going to talk about arithmetic and geometric mean and their relations also. Perfect. So that may lead to some interesting questions, at times bonus questions in your test paper. Now with that in mind, let's begin with solution of the set of questions we began with, right? So I hope you have some solutions to these questions. Let's take them one by one. So here is question number 1. State the first 5 terms of arithmetic sequence Tn equals to 3n. So Tn, that is the nth term, is given to us as 3n, right? So when we say first 5 terms, that means n will be equal to what? N will be 1, 2, 3, 4 and 5, correct? So you have to place these 5 terms. So let's put them one by one. So if it is T1, the first term will be 3 times 1, which is equal to 3. The second term will be 3 times 2, which is 6. The third term will be 3 times 3, which is 9. The fourth term will be 3 times 4, which is 12. And the fifth term will be 3 times 5, which is 15. So don't do the mistake of starting with 0. That's kind of important. Only natural numbers, right? So when we talk about discrete functions, then remember n belongs to set of natural numbers. Now that may not be mentioned in your test paper, but that is assumed, correct? Question number 2. State the first 5 terms of geometric sequence Tn equals to 2 to the power of n minus 3. So again the same thing. We have this formula Tn is 2 to the power of n minus 3. So the numbers which we are going to put will be 1, 2, 3, 4 and 5, right? So just calculate. So we have T1, which is equals to 2 to the power of 1 minus 3, which is 2 minus 3, which is equal to minus 1, correct? T2 will be 2 to the power of 2 minus 3, which is 4 minus 3, and that is equal to 4 minus 3 is 1. Now T3 will be 2 to the power of 3 minus 3, which is 8 minus 3, and that is equal to 5, right? So T4, it is not a geometric series, which you can see, right? So there's something wrong here. Anyway, so we'll just follow and produce the numbers, and then we can talk about it, right? So when I say T to the power of 4 is 16 minus 3, which is 13, and T5 is equal to 2 to the power of 5 minus 3, which is equal to 32 minus 3, and that is equal to 29, correct? So as you can see, this is definitely not a geometric sequence, right? So there is a typing error here. State the first 5 terms of, let it be of the sequence Tn equals to 2 to the power of n minus 3. Is that clear to you, right? So it's definitely a different sequence. It's not a geometric sequence, correct? So note, it is not a geometric sequence. Okay, so the terms I have mentioned, but there was a typing error, it seems, right? So this sequence is different, okay, exponential kind of. Okay, now here we have a very interesting question which says, write the first 5 terms of the following sequence. Now, you might use a calculator to calculate these values. So what I would like you to do is try this question, right? So I'm leaving this for you. So try it out yourself. Here is the solution. So when you plug in n equals to 1, 2, 3, 4 and 5, what numbers you're going to get? You are going to get the numbers as 1, 1, and then add these to get 2. 2 plus 1 is 3. 3 plus 2 is 5, right? So these are the numbers which you're going to get. So that is your answer. That's the solution. So I'll provide you with a link for solution. Is that clear? Okay. So for this particular question, I would like you to use the calculator, correct? Okay. Now that is Fibonacci series, right? This is very interesting. It's called the Fibonacci series, and That's the formula for it. Let's see how to calculate also, right? So what we do here is, let's do, first step is 1 over square root 5. So 1 divided by square root 5. Okay, so bracket close. Use calculator, okay? So we'll put 3 brackets just because this is times the whole thing. And then we have 1 plus square root of 5. Okay, and this thing is divided by 2, right? And then everything is to the power of, in the first case it will be 1, right? So let me write 1 here. Okay, sorry, power, right? So exponent. So we'll say exponent 1. Okay, and then we do minus within brackets. So we will write 2 brackets here. 1 minus square root 5. 1 minus square root 5 within brackets divided by 2, right? And then the bracket and to the power of 1, correct? And finally the bracket close. Okay, this is equal to what? So you get 1. Do you see this 1? Right? So you get 1. So when I try substituting the value, so when we try, so we get first answer as 1, as you can see, right? So we get 1. Now I'm going to change this value, the exponent, to 2, right? Okay. So this exponent I'm changing to 2. Okay, delete. I'm replacing it with 2. And now what is the answer? Again, as you see, we get 1, right? So it's clear. So we again get 1. Now we are again going to change this exponent to 3. So the third term is going to be what? Let's calculate. 3. Okay, equal to. So we get 2. Do you see that? Right? So I think it's very clear. Okay, good. Let's change this to 4 now. Okay. I thought I'd leave it for you, but then it doesn't really take much time with calculator. So we write 4 and equal to, and you get 3. Now we'll change this to 5. Easy. So with calculator it is very easy, but without calculator some of you might struggle. Okay, so let's say equal to. So we get 5, right? So you can continue with this series and you see it is Fibonacci series. Is that clear to you, right? So it is an extremely good formula to remember, right? And this is the formula for Fibonacci series sequence. Extremely important, and normally this formula is not given in the books, right? So it's a good knowledge-based question. Thank you. Here is question number 4. Determine the general term and the recursive formula for the arithmetic sequence 28, 20, 12, and so on. Correct. So we have a sequence which is 28, 20, 12, and so on. So as you can see, this sequence is decreasing by 8, right? So minus 8 each time. Right. So the general term Tn can be given as a plus n minus 1 times d. So in this particular case, a is 28, right, plus n minus 1, and d is minus 8. So we can now open the bracket. We get 28 plus, let me multiply this number with 8 first. We get plus 8 and then minus 8n, right? So add this, so we get 8 plus 8 is 16. So we get 36 minus 8n, right? So we get a general formula, and the general formula for us is, let me write here, Tn equals to, you could also write minus 8n plus 36. Is that clear? So determine the general formula and the recursive formula. Now what is the recursive formula? The recursive formulas you get based on the previous number. So when you have to define the recursive formula, let's write down here. For any sequence, you should mention starting with what at least, right? Sometimes you mention more than one term. So in this case, mentioning that first term is 28 can help us find the formula. Now we can say that the nth term is actually previous term, n minus 1, take away 8, right? So that becomes your recursive formula. Is that clear to you? Perfect. So these are the two solutions for our question. So that is your recursive formula. Perfect. So that's how you do it. Question number 5. Determine the general term and the recursive formula for the geometric sequence 640 minus 320, 640, 160 plus and so on. So this is a geometric sequence, right? So that means we have a scale factor. We are given 640 minus 320 plus 160. That means the value of r, which is the ratio of the next term minus 320 over 640, is basically minus half, correct? So this is the value of r, right? So the general formula Tn basically is a times r to the power of n minus 1. So in this case, a is 640, so we get 640. R is minus half, right, to the power of n minus 1. Is that clear to you? So that becomes your general formula, right? So we have general formula as shown here, which is Tn equals to a times r, which is minus half to the power of n minus 1. And the recursive formula is in terms of previous terms, right? So what is happening here? The first term for us is 640 and the nth term is previous term times minus half. Do you see that? So that is how you write it. You could also write this as Tn is minus half of Tn minus 1. Clear? So that becomes your recursive formula. You're already midway. Now here is question number 6. I'd like you to pause and answer this beautiful question, which is based on triangular numbers. Question number 6. Write recursive formula and general formula for the triangular numbers 1, 3, 6, 10. Now it is interesting to note that these numbers 1, 3, 6, 10 and so on, they are actually called triangular number, mainly because if you arrange them, let's say you have 1 here, right? Then 3 could be arranged in a triangle. Do you see that? Triangle. So 3, right? Now next stage is to just increase this, right? So what you get here is another triangle, and the number of dots on this triangle are 6. Correct. So that is how you could build your triangle, and you get the number of dots as 1, 3, 6, and 10, and that is the reason why this is called triangular number sequence. Perfect. Okay. Now let's see how to find general term. Now it is important to note that when we are talking about sequences, sequences could be arithmetic, geometric, or others, right? So remember this, when we are talking about sequences, they could be arithmetic, geometric, and others. So this belongs to the others category, right? So they could be linear, non-linear. There are different kinds of sequences, all kinds of sequences. So a particular pattern is being followed, then the definition of sequences work. Now here, what is happening? Now if I have to go from 1 to 3, I basically add 2, right? Then from 3 to 6, I'm adding 3, and then I'm adding 4. Do you see that? So that is how we are actually getting our sequence, correct? So the rule is when you add a number, increase it by 1 each time. Is that clear to you? Correct? So that is the kind of rule which is being followed. How do I write this as a general term? So what is going to be the nth term? So you can see that the number here, which is 3, could be written as, so the first number is 1, correct? So let me make a table to help this out and derive the formula, right? So as far as the first term is concerned, it is 1. The second number is 1 plus 2, and we get 3, right? The third number is 1 plus 2 plus 3, and we get 6. And the fourth number is 1 plus 2 plus 3 plus 4, and then we get 10. So likewise, what you see this is sum of natural numbers, right? So as you move, the nth number will be sum of natural numbers. So that should give you the formula, right? So the formula, if there are 4 numbers, you get 10. When you multiply the two numbers n, which is 4, times 5 divided by 2, right? So the general term here, Tn, will be equal to half of n times n plus 1, which basically is the formula for sum of natural numbers. Is that clear to you? Right? So that is how we are going to get the formula for this particular case. Right? Now, how do we get the recursive formula? Recursive formula, how do we get? You have to figure out that. Let's see that. That is to say, we have to see how do we get 10 from 6. If we know 6, how do we get 10? We are adding this number 4, which is our term number n. Do you get the idea? How do we get 6 from 3? We are adding 3, right? Which is n. So that is how you get. So we could write here recursive formula. If t1 is 1, then tn is tn minus 1 plus n. Do you see that? So that becomes your recursive formula. This is a very beautiful question, extremely important from test point of view. Perfect. So that is how you actually get your recursive formula for the given sequence. Is that clear?